Okay, as promised the last time, I said I will give some examples of the DDA algorithm. As I said, the DDA algorithm is a line generation algorithm. Now, we've been given 2 points. We have been given this question. We have to draw the line between 5,5 and 10,9 using the DDA algorithm. So from previous lectures, I was saying that when you have the DDA algorithm, then you always will be given the points. So using this Cartesian plane, we are to draw this line starting from A and B. Now, in order to draw the line, I said we will need to use a DDA algorithm to create the intermediate points that will enable us to complete the creation of the line. Now, to solve this question, so let's come to the solution of this. The first thing that we have to have in mind is the algorithm. That's the steps of the algorithm that we talked about. So we first of all would have to accept the starting and the end point coordinates. So in this case, it is A and B. Then we will calculate these values. So the x, so the step 2 is to calculate the x, the y. So moving again, so first of all, we have to create this. So let's represent A as 5, the coordinate for 5, 5, and B as the coordinate for 10, 9. So to find dx, which is the step 2, so we first of all, step 1 is to accept the points given. So step 2, find the magnitude of the x2 minus x1, and that of dy, magnitude of dy, which is y2, magnitude of dy, which is y2 minus y1. For putting in the values, we will have the x is equal to, this is x1, so x2, and this is x2. So we have magnitude of 10 minus x1, which is 5. So 10 minus this, which will eventually give us 5. Again, dy will also be equal to the magnitude of y2, which is this one, 9 minus 5, which will give us 4. Now the next step, which is step 3, says that when we have these created, when we have the calculation of dx and dy, we should find out to see if the magnitude or the absolute value of dx is greater than dy. If it is, then we'll represent dx by k. If not, then we'll represent it by y. Represent k by d and y. So let's try and find out from the step 3. We have dx, of course, is greater than dy. The reason being, and this is mainly because we have x, which is 5, greater than dy, which is 4. So in this case, k will now be represented as dx. So now we know that k is equal to dx. So and dx, as we already seen, is equal to 5, and that is in step 2. So the next thing is to go to the next step of the algorithm, where we are to calculate change in x and change in y. Now change in x is dx over k, and change in y is equal to dy over k. So moving on, we have to calculate change in x. So we have change in x is equal to dx over k, and dx, as we know, is 5 from the step 2, and also the value of k is also 5. So we have 1 as the change in x. dy is also equal to change in y over k, which is equal to 4 over 5, giving us 0.8. Alright, so we have change in y, x equal to 1, and also change in y equal to 0.8. Alright. Alright, so now that we have these, going to the algorithm, we are to initialize x equals to x1 and also y equals to y1. After we will display the values that we get, this will be the first intermediate point. Now let's try and draw a line. Okay, let's draw a line to help us in the calculation. And you should be mindful that the value of k is equal to 5. That tells us we have about 5 iterations to go through to be able to compute the line segment. Alright, so the first thing that we have to have in mind is the iteration number, which is represented, which we will be representing as I. The next one is to plot a round of x and a round of y. And after we compute x plus change in x, the last one will be to compute y plus change in y. Alright, so these are the headings that we go through to finish up the intermediate points. Now moving back again to this, we are to display x and y and also the x values as we see. The initial x values will be adding changing x and changing y to them. So now let's start with the first one. So from the iteration 0, that is the point A, we have 5, 5. So have 5, 5, and in x1 and y1. So those are the initial points that I'm considering. So at that point, to move on to the next one, to find the next x coordinate, x as we see is 5 plus change in x, which has been represented here as 1. Change in y is also 8, so we have plus y and y plus 1, and y is also equal to 5 plus change in y, which is represented as 0.8. So this will give us 5.8, and this will give us 6. So the next coordinate that we are going to think about, next iteration will pick the coordinates which will be the public. So that A is a 5, 5. The next one is the first intermediate point, which will be 6 and 5, 6, and 5.8. We are taking the rounded value of y, so it will also be 6. So we have x plus change in x. X now is 6. Change in x is also 1, so make it 7. Also would have 5. Would have 5.8. Plus 0.8, and that will be make 6.6. All right, so that is the iteration 1. for iteration 2, the new coordinates will be represented as 7, and a round figure of 6.6 making 7. And for x plus change in x, we will have 7 plus 1 making 8, and 6.6 plus 0.8 making 7.4. So that is the second iteration. So we go to the next one, which is the third iteration. We have the value of 8 and a rounded figure for 7.4 making 7. And also we will have 8 plus 1 making 9. 7.4 plus 0.8, and that will give us 8.2. So we're done with the third iteration. So for the fourth iteration, we'll have 9 and 8. That is the rounded value for y. Have 9 plus 1, that will be 9 plus 1, which is equal to 10, and also 8.2 plus 0.8, giving us 9. So that is fourth iteration. So at the fifth iteration, we have the value of 10 and 9. It basically is the end of the points, as you see from the coordinates given 5, 5 and 10, 9. Of course, if we were to compute the next one, we would have 10 plus 1 making 11, and 9 plus 0.8 making 9.8. So at this point, if we, based on the number of iterations, we'll end at the fifth iteration. As you can see, k is equal to 5. We ended at 10, 9. These are the intermediate points that needs to generate to be able to come out with a line. Now on the Cartesian plane, assuming we have here to be, okay, let's say 2, 4, 6, 8, and 10. And also on the y-axis we have 2, 4, 6, 8, and 10. Plotting the values. The first one is 5 and 5, which will be somewhere here. The next one is 6 and 6, which will be somewhere here. 7 and 7, somewhere here. And 8 and 7, which will be somewhere here. And 9 and 8, which will be somewhere here. Finally, 10 and 9 should be somewhere here. So that will be the line, and